In this video, I'm going to work through some of the solutions to working with radians at exercise level 2. I'm going to start with question 2, part 1. So we have 2 sine x cos x equals sine x. And if you've not done this question, please just pause the video and try the question before you watch the solution. Okay, so you might be tempted to start this question by dividing both sides by sine x. Well, that is really important that we do not divide by sine x, because we will lose some solutions here. So what you should do instead is you should factorize to make sure we get all of the solutions. So to do that, let's get all of our stuff on one side. So let's subtract sine x from both sides to get 2 sine x cos x. Subtract sine x equals 0. And if we take a factor of sine x, we get sine x, open brackets, 2 cos x, subtract 1 equals 0. And we can see, therefore, we've either got sine x equals 0, or we have 2 cos x minus 1 equals 0. So 2 equations there to solve. Okay, and actually we've not written this down, but the question asks for x to be between 0 and pi. So x is between 0 and pi. And actually the question says theta here, but they do mean x, because x is the variable we have. So if we go about solving these, we're thinking about sine x equals 0. So let's draw our graph of sine between 0 and pi. And actually sine between 0 and pi just looks like this, with a maximum value of 1, 0 here, and pi here. So we can see straight away, I hope, from the graph that x is either 0 or pi. And if you put sine inverse of 0 into your calculator, sine inverse of 0 is 0, but please make sure you get this other solution of pi, because we can see that sine x of pi is also equal to 0. But we also now need to solve our second equation, which is 2 cos x minus 1 equals 0. Well, that is clearly equivalent to saying cos x equals a half. So if we look at our cosine graph between 0 and pi, our cosine graph looks like this, and we want cosine x equals a half, so half is about here, and we can either put into our calculators x equals cosine inverse of a half, or this is actually one you probably should know, that should give you pi over 3. So the solution to this is x is equal to 0, pi over 3, or pi. And if you are doing this on your calculator, make sure you are in radians mode. Okay, the next question I would like to look at is question 3, part 2. So we start off with tan squared x is equal to a third. And in this question, we are asked for x to be between minus pi and pi. So let's write that down. We've got x is between minus pi and pi. And that's not quite right. This is strictly greater than negative pi. Okay, so what should we do first? Well, the first thing we should do is take a square root. But whenever we take a square root, we need to remember we also need to consider the negative. So we have plus or minus the square root of a third. Well, we know that that is just the square, plus or minus the square root of 1 over root 3. And we want to solve this here, so we could go x is equal to tan inverse of 1 over root 3, and x is equal to tan inverse minus 1 over root 3. Well, making sure your calculator's in radians mode, This again is one you should know, but this is pi over 6. And this one here is going to be minus pi over 6. But we need to be a bit careful because these aren't the only solutions. So let's draw out our tangent graph again. And we're going between pi and minus pi. So we have pi here. We have an asymptote at pi over 2. We also have an asymptote at negative pi over 2. And then pi here. So if we think about 1 over root 3, which is approximately about here, we can see that we should have two solutions here and here. And then at negative 1 over root 3, we should have two solutions here and here. Well, let's think firstly about this one here. Well, what is this? Well, we can see that, and that should say negative pi there. This is just pi, or 180 degrees if we're thinking about degrees, less than pi over 6, which we have already found from our calculator. So we have x is equal to pi over 6, but also pi over 6 subtract pi. What else do we have? Well, we know from beforehand we have minus pi over 6 here. But also we have this root all the way over here. So if we, let me just put that blue line back in. If we want to find the root over here, this is just pi more than minus pi over 6. So we have x is equal to minus pi over 6, but also minus pi over 6 plus pi. And if we calculate all of those, we get x is equal to plus or minus pi over 6, but also plus or minus 5 pi over 6. Finally, I want to look at question 3, part 4. And we notice here we're going to have to do something with this because we have a sine x, but we also have a cosine squared x. And what we should occur to us here is we've got a relationship between sine squared and cosine squared. We know that cosine squared x add sine squared x is identical to 1. So cosine squared x is identical to 1 minus sine squared x. And if we make this substitution for cosine squared, we're going to get an equation that just has sines in it. So let's do that. We should get 4 subtract 5 sine x equals 2 lots of 1 minus sine squared x. Expanding that out, we get 4 minus 5 sine x equals 2 minus 2 sine squared x. And then I'm going to collect all my terms on the left-hand side. So adding 2 sine squared x to both sides, minus 5 sine x. And then subtracting 2 from both sides, we get plus 2 is equal to 0. And that is in a quadratic equation in sine x. And if you want to solve that on your calculator, or you want to use the quadratic formula, go ahead. I'm going to try and factorise this. So we know we want a positive here and we have a negative here, so they both need to be negative, and they both need to multiply to make 2, so our only options are 2 and 1. We need some multiple of sine x here and some multiple of sine x here, and we want to get minus 5, so if there was a 2 here, we would get negative 4x, negative 4 sine x, negative 1 sine x, so that is correctly factorised. So what do we have? Well, we have two equations in sine x. We have either sine x is equal to a half, or we have sine x is equal to 2. And again here, we've not written it down, but we are looking for x to be between pi, negative pi, and pi. Okay, so let's draw out a sine graph between pi and negative pi. Well, a sine graph between pi and negative pi looks like this. And we want sine x equals 2. Well, we can see straight away, if this value here is 1, then sine x equals 2 has no solutions. But we do need to make sure we write that down. We can't just ignore it. So sine x equals 2 has no solutions. If you try sine inverse of 2 on your calculator in radians mode, it will definitely, well, even in degrees mode, it will definitely give you a math error, right? But we definitely do not start writing math error. We are not year 8 students anymore. We write down this has no solutions. Okay, but we do need to deal with sine x equals half. So sine x equals a half is about here. And we can see there are 2 solutions to this. So we're going to get x is equal to, well, sine inverse of a half is pi over 6. And either you can do that in your calculator in radians mode, or that's probably one you should know. So we know this is pi over 6. But this distance here is pi over 6. So this distance here is also pi over 6. So we also have a solution of pi subtract pi over 6, which is 5 pi over 6. So we have 2 solutions to this equation between negative pi and pi, which is x equals pi over 6 and 5 pi over 6.